Good afternoon, everyone, and welcome to this first webinar on advancing cybersecurity in healthcare. My name is Giada Martello, and I'm a communication and dissemination specialist at Martel Innovate in Switzerland, as well as a communication manager for the CYLCOMED project. Today, I'm going to be your moderator. This webinar is the first of this EU project cluster, and it wants to address the critical need to raise awareness on cybersecurity challenges in healthcare. In this webinar, you will hear from representatives of 4 innovative Horizon Europe projects, CYLCOMED, CYMEDSEC, MedSecurance, and NEMECYS, and how they are working to deploy solutions in the healthcare domain. So why is this topic important? Cyber attacks can affect any sector, but in healthcare, where cybersecurity often lags behind, the stakes are especially high. Disruptions caused by medical device malfunctions can endanger lives, and the theft of sensitive patient data can have severe, long-lasting consequences. This is not the only reason why such projects are crucial, and you will hear more about them in detail today. Together, these projects aim to make healthcare systems safer, more secure, and resilient for the benefit of patients and hospitals alike. This webinar will end with a dedicated Q&A section. You will be able to submit your questions during the whole webinar in the chat below, and we'll gladly address them towards the end. And last but not least, some minimal housekeeping rules. Please keep your videos and microphones closed. The webinar will be recorded and will be distributed to participants. So without further ado, I would like to introduce our first speaker, Giacomo, a senior innovation consultant, who is going to provide to us an overview of the CYLCOMED project. So Giacomo, thanks for joining, and the floor is yours.
Thank you, Giada. Thank you all for joining this event. So I'm going to share my screen now with my slides. So just 1 second that I do it. And there we go. Hopefully. Yes. So it's my pleasure to introduce CYLCOMED project on behalf of the World Consortium. So I'm one of the project partners representing Martel Innovate. My background is technical, so I will try to give an overview of the project from all the different points of view, but I may be more precise in the technical stuff than in the rest of the content. So CYLCOMED, the overall project goal is like providing a cybersecurity toolbox for connected medical devices, and this project is an answer to the call in the health sector of 2022, and you can see CYLCOMED. This is the acronym of a cybersecurity toolbox for connected medical devices. Now, it's needless to say, as Giada mentioned, that nowadays the healthcare sector is under like constant attack, and they are reporting in the news of several issues with connected medical devices. And this doesn't have only an implication on the technology, but also comes with like privacy risk, security risk, ethical concern, and legal challenges. And that's why in CYLCOMED, we are a consortium of several partners with different background and multidisciplinary knowledge that would like to address these from different point of view, not just technological, but also taking care legal, ethical, and also having the citizen and the patients as a center of our research. This is a consortium. So as I said, I'm representing Martel Innovate, which is one technology provider and the leader of communication and dissemination and impact creation. Giada is a colleague of mine, and she's in charge of that part. And the other technology providers are Media Clinics in Italy, Atos Eviden in Spain, together with XLab, the IGB, and those are the main technology provider. Then we have 2 research institutes, Innov in Portugal and Q11 in Belgium, that are basically taking care of the legal, ethical aspects, and most mostly also on the risk management part of the project. And then we have several pilots, La Charité, the hospital in Germany, who is also the coordinator. And we have the Ospedale Pediatrico Bambino Gesù in Rome and the Fondazione Hospital Niño Jesús in Spain. As I said before, the project is multifaceted and has these three main steps in his life. So we first assess the current cybersecurity landscape in connected medical devices. We look into legal and regulatory requirements and what is existing and how we can improve it if we can. And then we look into baseline standards, best practices, just not to reinvent the wheel twice. And based on this assessment, what we want to do as the goal of the project, we want to ensure confidentiality, integrity, and availability of private data, since they are very sensitive one, but also preserving the patient's health and safety. And here in the delivery are the three main achievements that we would like to achieve inside the project, and that we are achieving because it's already 2/3 of the project now. So we have one risk assessment framework that it's capable to indicate if a certain development or a certain case manifests some risk and how to overcome them. And I have one slide on that. Then the second major outcome of the project will be the toolbox that is also in the title, that it's a set of IT tools that will ensure the confidentiality, integrity of the data, the protection of the patients, and so on. And the third outcome is basically the run of the pilot studies in some relevant scenarios, thanks to our pilot users. These are the main objectives, and we translate every objective in one specific work package. So as I mentioned before, we have ethical, legal, and regulatory aspects that we are also providing recommendation about. That will be work package 2. And the next slide will show the interconnection among these work packages. We look into standards, guidelines, and best practices. As I mentioned before, that will be that is the work package 3. Then we work together with methodologies and tools and to create the cybersecurity toolbox, and that's it. These are work package 4 and 5. In work package 6, we do the integration and validation, and finally in work package 7, we disseminate and amplify the results of the project. This is the interconnection among the work packages. As you can see, legal, ethical, and regulatory work package, it's basically influencing all the major ones. In particular, the development that is himself, depending on the risk management and the integration, it's creating these synergies and these outcomes. Now, going to the legal and ethical framework, so this is the starting point, and this is on Q11 that basically analyzed the several legislation and applicative norms about cybersecurity. So we look into the data aspect, into the cybersecurity aspect, but also into the AI, because we're making use of some AI tools. And then also on the specific law of the medical devices, and everything it's driven by the ethical requirements and ethical principles. So, and based on these principles, we influenced all the rest of the project. In particular, the risk-benefit scheme and also tool. So it's a bit full of information, this slide, but the main concept is that we had a several-step process in which first we analyze the risk-benefit in general. So what is the typical way of looking into risk-benefit and how to mitigate risk and to overcome them and to assess them. And then we look into the specificalities of the medical devices. And this is all in the one side of the screen. before the errors. And based on this analysis, on the other side of the arrows, so where the two arrows I'm pointing to, we derived a set of rules and a model of the data, model of the concepts that they operate together. And this is thanks to the partner Innov. And all this study, it turned into a risk management framework, which is a tool where you can introduce your variables and constants and risks. And then the tool is giving you also graphical the risk, provide some suggestions how to overcome them. And that will be the first outcome, as I mentioned before. Now, the second one is the toolbox. The toolbox is a set of several tools. Each of them it's addressing a particular aspect of the cybersecurity. So we have tools for the anomaly detection and log analysis for the devices, and these are provided by our Spanish partner, by XLab as a partner, and also by RGB, if I'm not wrong. And then in the security and deployment and configuration of devices is the Mender tool that we are providing as Martel, and the decentralized and user-centric identity management to make sure that the identity is maintained. It's from Evident-Atos, this one for sure. And the COPA on the functional and attribute-based encryption is still provided by Martel. The integrity tool for legacy, the device integrity check and Ansible playbook, it's once again provided by, I think, RGB. And the CYLCOMED dashboard is provided by Evident-Atos. And the dashboard basically would provide an integration of all the information from the different tools. So for example, CIOPA is allowing people to, not people, but person in charge of data of the patient to assign permission to be accessed or not this data by authorized persons. While Mender, for example, is making sure that the devices that are deployed are always up to date in terms of firmware, and then monitoring their status. The third outcome that I mentioned at the beginning are the two pilots that we are running. So the pilot one, it's within RGB in Spain, and the pilot two is by the Hospital Bambino Gesù in Italy. The first pilot, it's about an infusion pump controller that basically you can have a treatment at home, and the medical device is basically transmitting some data via a security layer. And this is would be in a control laboratory experiment. So it's close to the real scenario, but it's not the real scenario because there are many, it's very experimental, and this is a real, so the partner is really developing something new here with a certain criticalities that we cannot test it in production, let's say so, in a very technical term. While the second pilot, it's with real patients, that they are pediatric patients that are monitored by the tools developed by the partner, which is the, I'm sorry, I forgot the name now, Media Clinics, yes. Media Clinics, they provide the technology for this monitoring. And together with the hospital, they first of all, and that was one of the most challenging things inside the project, was to develop a protocol to basically be able to have the hospital granting us the possibility of doing experiments with real patients. So the protocol was also an outcome that is not listed before, but is a great achievement and is a great lesson learned also for us. And in this pilot, there are several other issues, not on the technical side, but also, as I mentioned, the approval of the clinic protocol was really quite an achievement, because it requires a lot of legal, ethical investigations. So this is basically CYLCOMED in a nutshell. So I invite you to keep posted, because, as I said before, we are now like 2/3 of the project, so it's going to finish next year, and some of the tool will be probably released, so can be used also by others. And there will be many other communications and activities in the next year. Thank you, Giada, for having organized it. And yes, we wait for you on the website and the newsletter. You can subscribe it easily.
Thank you, Giacomo. Thank you for having presented the project on behalf of the whole consortium, and for highlighting the vision, the pilots, and everything that CYLCOMED is doing. We are now continuing with our next speakers, Oscar Freyer and Max Ostermann. They are research associates at the Technical University of Dresden in Germany, and representatives for the CYMEDSEC project. So they are going to illustrate initiatives to boost cybersecurity for networked medical devices within healthcare infrastructure, focusing on seamless integration with hospital networks and ensuring data integrity. So the stage is yours.
Hey, thank you very much. A warm welcome. I will now start sharing my slides. And now you should be able to see them. So yeah, very welcome, and thank you for the nice introduction. So my name is Oscar. Max is here with me. We are both researchers at Technical University of Dresden, specifically at the Uniclinic there, and we are here as representatives for CYMEDSEC. And as Giada already said, CYMEDSEC is also a European project focusing on cybersecurity, but our angle is IOMT in the hospital at home. So we are not dealing with hospital level care, we're not dealing with hospital infrastructure and hospital care, but we're specifically looking at the hospital at home, or at the patient's home environment. We are a consortium out of 12 partners. One is a associated, so 11 full partners, and one is a associated partner from Switzerland. We have partners in 8 EU countries and 1 in Switzerland. And among them are 2 hospitals. So 1 hospital in Portugal, 1 hospital in Italy. 4 research institutions, which is us in Dresden, but also the VUB in Brussels, the Backhausen Institute also in Dresden, and the Athena Research Center in Athens. Then we have 1 medical device manufacturer, which would be Humana in Malta. We have 3 infrastructure providers, which is Secunet, Particle, and Medisonte. And we have 1 standardization body, which is Austrian Standards. The goal of CYMEDSEC, or the main question or main problem, is how to foster EU healthcare cybersecurity. And for this, we have kind of 4 main pillars. First pillar would be cybersecurity by design. The second pillar or output would be the benefit risk toolbox. Then the third pillar would be societal considerations. And the fourth pillar, the real world studies. So starting with cybersecurity by design, we are planning and thinking about and developing methods for building security into medical devices right from the start, and also methodologies on how to assess this. For this, we have several activities. We will come to that later. And here again, the focus is connected healthcare technologies, specifically Internet of Medical Things. The next thing would then be the benefit risk toolbox. So as you probably know, the benefit risk analysis is a very important part of cyber of the medical device regulatory process. So before devices are able to enter the market in the risk management, they need to have this benefit risk analysis, and there they have to assess whether their device poses kind of risks that are too high to be allowed to enter the market. So the goal for each manufacturer is to have a positive benefit risk assessment or analysis. And we want to develop, or we are currently in the process of developing tools which are a combination of checklist and automatic tools that help manufacturers to easily do that. And our goal is to publish them or to develop them in the open source manner, so people can just use it via GitHub, for example. Next part is societal considerations. So we pay specifically attention to the ethical and legal and privacy considerations. So one of our partners, VU Brussels, is, for example, an expert in those domain, and they're conducting rigorous research in this domain. And the fourth big pillar is the real world studies. And the goal here is to kind of simulate the cybersecurity requirements or the cybersecurity infrastructure together with hospitals and with patients in the rural country, or in the countryside in Italy. Maybe a quick overview of our timeline. So we started a bit later than the rest of the project. So our start date was November 2023. So we just finished our first year, and there is more to come. So we are running for 4 years in total, and we aim to finish in October 2027. As you can see here on my slide, we have some work packages that have already begun and some work packages that are yet there to come. So we are currently conducting guidelines research. We're working on the BRA methodologies. We're working with our partners on the IoT fleet management aspects and on the toolboxes. And later then we will kind of evaluate everything in the context of the case studies. Besides that, there are some activities that are happening all the time. For example, the ethical monitoring or the standardization activities together with Austrian standards. As we are researchers, so Max and I, we're focusing on the scientific outputs today, which we already have some. So as you can see here, we have a number of publications in peer-reviewed journals and preprints already available that are kind of our the summary of our results, and they're part of our deliverables. And we publish them. We are on the way of publishing them. First one was kind of an early result, which is kind of an imaginary scenario of a ransomware attack on a hospital-at-home system, and kind of in a narrative way or in an entertaining way goes through what would happen if such an event would take place to highlight the risk associated with such attacks. Then we have one systematic review on benefit risk analysis methodologies. So here we wanted to scope the space, what is already out there, what is used for benefit risk analysis of medical devices. And this then leads to another activity, which would be developing new methodologies or proposing new methodologies that can be easier used by manufacturers. And the next thing is a scoping review of cybersecurity in the benefit risk analysis specifically. What we did here is we searched available guidelines from IMDRF member states and international standards organizations, and we had a look into how those standards and guidelines define the benefit risk analysis, because as I already said, it is super relevant for medical device manufacturers, but is to some degree unclear how cybersecurity should feed into that. So we're not sure how the risk management for cybersecurity should look like, or the guidance is mostly ambiguously defined. And we kind of wanted to highlight this gap and wanted to give the audience, the scientific audience, an overview of the standards and of this gap that is existing there, so that we can, in the next step, propose new methodologies and work on new methodologies. And for the next project, I will hand over to Max. Max, are you here?
Yeah. Hi, everyone. I'm here as well. So for the next few slides, I'll be the one taking over. Other aspects that we've considered up until now are, as Oscar has previously mentioned, mostly on the hospital at home infrastructure. So in the first place, what's been our main goal for the first year here has been to analyze, okay, what could potential issues or threats or weaknesses, vulnerabilities and the like in the hospital at home look like. For example, so for this, we had partners performing what's called a threat analysis, which analyzes threats in the hospital at home systematically, basically progressing what is previously been published in the Nature piece on the imagined attack by analyzing the entire thing systematically again, and on determining that there's a large number of possible attack vectors to such a system. For example, if we have a look at the next slide, we could see that even one single attack could, for example, have a fallout on the entire system and allows an attacker to basically do whatever he pleases with the patient's home system, from breaching the private data by breaching confidentiality to manipulating the data that's sent out to the remote monitoring service by tampering with the records, or just basically blocking any traffic that's there, which would also be the worst case. Then further analysis is also, okay, so what happens if any of these breaches happen? So it's currently in progress, specifically from the TU Dresden side, for example, is an assessment of how any of these potential issues could actually affect a patient's health, how harmful any of these breaches would be on a very risk assessment kind of level. So following the ISO norms 24971 and 14971. So yeah, these protocols will be published rather soon, among other publications that are currently in the process of peer review, but not yet currently available as preprints. For example, if we have a look at the next slide, these would be, as has also been mentioned by Giacomo, a risk analysis looking at some of the best practices and standards, looking at the guidelines as well, the threat analysis I have just mentioned. And once all of these are out there, then our overarching goal tends to be to also, again, following the analysis of current best practices, to establish a set of best practices to help to improve the standards that are out there, specifically for the hospital at home, for this remote system where things can change rather drastically. And also, along with our industry partners, with, for example, SecuNet, offer solutions to some of the problems that we showcased in the first year, so that not everything is doom and gloom following our assessments from the first year, but that in the following years we can also show, okay, here's the specific ways as to how should people, or how should developers, patients and hospital providers go about things, what do they have to consider, and how do they prevent and mitigate potential threats. And the entire thing will, as Oscar has already mentioned, also be tested in the field with other partner hospitals from CSS. And I think that's
maybe quickly jumping into that. So yeah, as Max already said, so we have a lot of deliverables upcoming. Here at the slide, you can see kind of the deliverables that will be available until the end of the year or early next year. So as Max already said, the risk analysis and a gap analysis of MDCG 2019-16. We know that there is already something published from the other Horizon project on this specific topic. We also want to contribute here, and will publish will publish a piece in this space as well. Then a systematic review on the device management. So how to manage IoMT devices with updates, with location tracking, etc., in the hospital at home. Then we will conduct, or we are still currently conducting and are in the final stages of writing a systematic review of best practices, which just describes the current and emerging best practices that are out there described by researchers. And then we have a threat analysis based on the STRIDE analysis we already created or delivered, and then a guidelines review of current EU-level guidelines on cybersecurity of medical devices. And besides that, so those are our research outputs, but besides that, we are currently heavily working on our demonstrator that showcases our infrastructure, or how we see cybersecurity in the IoMT, in the hospital at home IoMT. Our more technical focused partners, Backhausen Institute and SecUNet, they are working on secure operating systems and secure chips. So chips on a chip level. Those are more application focused outcomes. And yeah, I think that's it from our side. And please check out our website if you want to know something more. If you want to know more, or reach out to Max, me, or Professor Gilbert, who is the coordinator of the whole project. Subscribe to our newsletter and check out our our video that shows our grand vision, what to achieve within the next 4 years. Thank you very much for your attention, and we are here for questions at the end of the webinar. Thank you.
So thank you, Max and Oscar, for presenting CYMEDSEC on behalf of the whole consortium, and for highlighting the very insightful scientific section of the project, as well as the risk chain and the next steps. So our next speaker in line is Nabil Moukafih. He is an assistant professor of security engineering at the University of Warwick in the UK, who is going to highlight how MedSecurance is advancing security for safety assurance in medical IoT systems. So Nabil, the stage is yours.
Thank you so much for your introduction. Hello everyone. As mentioned, today I will be representing the MedSecurance Consortium partners and give you an overview of the project and introduction about the core objective that we're trying to do, where we are, and what are the main aim of the project. So obviously, as my colleagues from the cluster mentioned, so it's our products also falls into the cluster of protection, ensuring security and safety of medical devices. So obviously, technology today has become a core part of healthcare, and thanks to that, we started seeing many improvements in that area. So we have wearable devices, bed monitors, infusion pumps, etc. So these devices, they monitor the health of the patient. They collect data, health-related data, vital signals. They manage treatment, and even you can use them to do complex diagnosis, like if you have a smart surgical devices. So obviously, the more reliance we have on such devices, the more they are interconnected, the higher the risk of security breaches and data privacies it also gets. And this in this context, it not only puts the security of the medical devices at risk, but also, since they are in a healthcare environment, they put the safety of the patient at risk. So MedSecurance, what it does mainly, it aims to enhance the decision making in IoMT cybersecurity by making it more effective, and creates approach and to understand how all the different components interact each other. And you can manage your risk, follow regulations, and ensure that your IoMT environment is secure and reliable. So we have a couple of objectives that I've thought I would divide into a couple of slides. So first, what we're trying to do, so we have 6 work packages, and in each work package we have a task or an objective that you're trying to do. So I'm listing here the first objective is we actually look at everything. So we look at our standards in the InfoSec into the medical devices. We look at risk related standards. So we review architectures, the different IMT architectures into an IMT devices. We look at communication protocols, security communication protocols, and also in the first work package, we've designed what we called a threat and vulnerability risk assessment methodology, which is an approach that allows you to follow your risk at the system, at both at system and component level, and track your security requirements at these levels, and to give you a more enhanced decision making. So also one of the objectives is if we develop an assurance toolbox. So this assurance toolbox is wraps around the TVRI methodology that we've developed in the work package 1. And also the different tools that the other R&D partners are also leading in development. So the ontology, the system modeling, and the security architecture tools, the tools that I use to look at security protocols for medical devices, tools that I use for vulnerability identifications, tools that I use for risk assessment, and also the tool that is used for the assurance case construction. So this will materialize all the processes and the methodology that is proposed by MedSecurance for decision making. So this methodology, once the tool is finalized, we've launched the first prototype, and we're working with the use case and stakeholder, but to ensure validation of the use cases and the approach. So we've built and working with them. We've collected some requirements, the requirements about the use cases and the technical requirements that we have in the tool. We ensure that mapping, and we can ensure that there's a validation between the tool that is developed as part of the MedSecurance project, and also the industrial expectations. So obviously, the final goal, which is to provide, and this is G1916 recommendations. So and try to look at the standards where we can contribute, since all these cluster projects are looking at the security and safety of medical devices from different angles. So that's also a final goal that we're trying to do. So this slide, so it puts it into more context. So where MedSecurance falls into? So what are the needs? What are the approaches and the benefits? So I've touched upon a lot of these points in the previous 2 slides where I talked about the objectives. But one of the core benefits is the development of the assurance toolbox by automating the collection of the assurance elements and automating the repetitive tasks that are generated from system models, vulnerability scans, and code annotation, and to reduce the manual effort required to do so. So here, to explain from a higher overview, the different information flow that is used into the toolbox. So as you can see, the assurance case construction. So MedSecurance comes really before the certification body, the assurance package generation. So in an assurance system assurance process, to use an assurance case to present clear and evident bag argument for the system safety and security, and all this information that is collected about the system details, the test result, the vulnerability scans are compiled into the assurance package. So this assurance package is reviewed by the certification bodies, and if this assurance package meets the required standards, then the certification is granted, which will ensure that the system is safe and reliable before deployment. So what we do is, what the toolbox is doing is that it collects all what we call the evidence that is put into the assurance package. So our tool, for example, it's one part of the evidence is the generation of vulnerability scans. This is the TVRI methodology that provides threats and vulnerability and risk-related information about medical devices. There are also evidence collected from other tools about the architectures and the meta models of the tools. the modeling and the ontology of the tool, and also the analysis of the security related protocols. So all this information, all these tools or core sub-tools of the assurance toolbox, they work with the assurance tool to construct or to create that assurance case that will aid and facilitate, automate the certification process. So this is from a high level overview how the tool is going to work. So currently we are at work package. So we're in the mid-work package 3 and 4. That means we've released a first prototype of all the tools. And also we're working with work package 4, which is the validation of the use case. We're working with the use cases to test the tool, get the feedback, and improve the tool by reviewing the requirements previously collected. So one of the things that we're doing is Warwick is doing as part of the toolbox is the threat and vulnerability and risk assessment process. So this is the methodologies we proposed. Apologies, this is readable. This is not readable. It's not to be read, but it's more of a giving you a review of the system and components based approach for risk assessment. So obviously it's a process based approach at this stage. At work package stage, but to ensure the security and safety of medical device. So as you can tell by the structure, it is based in the ISO 20005 for risk assessment. So it includes all the core activities. So on the left, you see the risk identification, the risk analysis, and then on your right, you see the risk treatment and monitoring and review and the reporting. So the TVRA has a list of inputs and outputs. So at the beginning, so we collect information about the use case at hand, the architectures, we understand the components, the relationships between each component, what are the requirements from the stakeholder point of view, and what are the methodologies we'll be able to follow. So once we take that input, we'll conduct some preliminary risk assessments to generate scenarios. So the scenarios are using information aided, what we call catalogs, threat catalogs, and vulnerability catalogs. They contain information, applicable threats and applicable vulnerabilities for a given use case, and try to map or provide a mapping between which threats relate to which use case, and we provide scenarios. So next, with the risk analysis, we analyze the impacts of the threats. Which threat is more likely to be exploited by which vulnerability, and we produce risk information, and then we evaluate these risks against predefined criteria and assessment criteria. So the second part, you actually, once you provide once you have information about the risk information, you have to recall, you use your security requirements and the stakeholder requirements to make sure that you propose appropriate and relevant security controls that will reduce the risk information. So this also has been materialized. So we have a set of tools, because we're talking about threat modeling, we're talking about vulnerability analysis, and we're talking about risk assessment. So certain activities are model-based, which means you have a model, you draw your risk and your analysis. But certain activities like vulnerability analysis, it's an active analysis of the system. We run scans, we capture CVEs, and we link those information to risk-related information to provide a full detailed threat and vulnerability and risk assessment for medical devices. So we have 3 use cases. So the target impact from MedSecurance is we work on use cases in the hospitals and clinics and home care settings. So we do have remote patient monitoring use cases. It's one of the first use cases that we've actually started to work on. So we aim to produce measures to identify and address security risks and gaps. So we aim to risk benefits analysis and decision capabilities for IMT devices, provide methodologies for automating assurance toolbox and ensuring IMT's cybersecurity, and also provide guidance that cover challenges posed by medical devices. So the main aim is we want to lower the cost or the development cost by generating that assurance case for safe security and safety and dependability of connection with medical device for a wide range of Europeans. And we're doing that through the information workflow that I've previously talked about. So we have 13. We have partners all across Europe. So it's 12 projects partners in many countries, and we have 3 use cases. So one is on hospitals, and one is a remote use case with specific devices. So we are in the first mid evaluation phase. So we have released the prototypes. Currently, the tools they still work at independently. We haven't integrated with into the integrated platform for a more usable demo. But we hope in the next webinar, perhaps we can give you a more closer look to the tool. And that concludes my presentation. Thank you for your attention. If you have any questions, I can take them by the end.
Thank you very much, Nabil, for highlighting the MedSecurance project and on behalf of the consortium and the key elements of MedSecurance assurance, including results and the work that you're doing. Finally, our last speaker is Christos Androutsos from NEMECYS project. Christos is a software engineer at the University of Ioannina in Greece, and he's going to dive deep into the security by design aspect of connected medical devices and illustrate how NEMECYS is working to boost it through the development of cybersecurity assessment techniques and tools. So Christos, the stage is yours.
Okay, hello everybody, can you hear me? Okay, perfect. My name is Christos Androutsos. I'm a software engineer, Giada said, from the University of Ioannina, and specific from the Unit of Medical Technology and Intelligent Information Systems. And I will present the NEMECYS project, which is related to healthcare practitioners, such as device manufacturers, device integrators, and operators, in order to help them comply with medical device regulations and build-in cybersecurity related to medical devices and connected medical devices. So we are 11 partners as a consortium in NEMECYS, with each of us has a different role, either a literature review, either the development of cybersecurity tools. So we have case studies, and we have, of course, risk-benefit analysis schemes. So regarding the systematic review, we have already conducted an analysis review. We have found some specific documentation and specific documents from the literature in order to conduct a gap analysis and try to find theoretical gaps in this documentation, such as the lack of focus in the cybersecurity or the more general, the generic requirements that are addressed through the documents, and the complexity, of course, that most of the documents have. To provide a view for the current limitations and challenges that are related to cybersecurity of medical devices, and of course to extract and identify guidelines and recommendations provided to all of these documents in order to address cybersecurity. From the systematic review that has been conducted in the NEMECYS project, we have identified 426 best practices from different documents that serve as guidelines and recommendations for medical device manufacturers, integrators, and operators. In order to collect feedback from stakeholders that were also internal in the project and outside of the project, we conducted a pre-workshop. We conducted, first of all, workshops and some surveys in order to collect this feedback. So we sent them a pre-workshop survey that were filled from 19 participants. Then we conduct a workshop in several different countries, and then we had the post-workshop survey that were sent after the conduction of the workshop. The results from this workshop was that we identified 26 challenges in a top rank of 5 challenges that's depicted in the diagram, with the first one to be the difficulty in order to keep up with the evolving threats. Regarding the tensions for the medical device, in order to use the medical device regulations, we found the strictness of cybersecurity versus the fast evolving technology. and 37 final recommendations, which were the compliance guidance, support, and incentives, the compliance examples and the use cases, the security awareness, the frequent updates, and the list of threats and vulnerabilities. In the NEMECYS project, of course, this is a core part of our project, is the development of NEMECYS tools that help the medical device stakeholders to comply, of course, not to comply, to be in line with the cybersecurity. So we have 10 different tools with different intended use of each tool. We have a risk and threat modeling tools, such as the Chorus tool, in order to assess complex connected medical device systems, aim to balance security and privacy with patient safety, of course, and utility goals. We have the Spider Risk, the SSM tool, which is another risk assessment tool for complex connected medical device systems. Basically, it's a knowledge-based simulator in order to identify risk and propose risk control measures and provide a bridge between the cybersecurity and the healthcare, and of course, the risk-benefit analysis. We have the AI privacy risk assessment tool in order to identify and leak identify if the sensitive information can be leaked regarding the training datasets. We have the network assessment tool, which assesses the security of all the devices connected to the network infrastructure. We have the common state-of-the-art repository tool, which is a knowledge base of all the documentation that medical device manufacturer, integrator, or operator needs in order to comply with specific regulations, standards, and best practices. We have the cybersecurity trainings and best practices tool that provides awareness training in order to enhance the cybersecurity in healthcare stakeholders and how they can interact and deal with a given situation. We have the secure IoT service mesh for secure communication and data exchange between the medical devices and the cloud-based platforms. We have the secure software development pipelines, which is related to the DevSecOps, and the aim is to apply security by design through the whole development lifecycle of the device and for the software application. We have the firmware fuzzing tool, CPU emulator, in order to find vulnerabilities during the development of the devices. We have the procurement and compliance tool for the device operators in order to help the procurement process for the medical devices and, of course, adhere to regulatory compliance. And we have the case studies. We have 2 pilots in our project, and these case studies will validate, of course, the tools that I mentioned earlier. The case studies also will validate the existing MDCG 2019.16 guidelines. The systematic review that has been conducted in the Work Package 1 will be also validated from the case studies and will provide gaps in practice, and these gaps will be compared with theoretical gaps identified in the review. Of course, connected medical device scenarios has already been developed in the NEMECYS, and the case studies will assess the fitness of the guidelines in these scenarios, the validation of the tools, and then the guidelines, the rest of the guidelines from the systematic review. In NEMECYS, we have already defined the case studies in terms of the device description and the intended use of each device, the technical features and the components that constitute a medical device, the 4 medical devices that we have in NEMECYS, the current cybersecurity challenges and vulnerabilities that these devices have, some deployment examples and scenarios that are targeted to each of the case studies in a different operation environment, and cybersecurity risks, a baseline list with the risks that currently the device have in order to be compared with the tools. All of the case studies will be examined in 1 or more different intended uses, and this will result to the scenarios that have been described in NEMECYS, The design process will use as template and the actual medical device design history file, and the content will be limited to cybersecurity, and all the scenarios of use will be implemented based on a specific ISO 13485, and of course some other standards like the medical device regulations and the ISO 14971 for the risk assessment. We have 4 case studies with different intended use, as I said. The first case study is related to home dialysis. So it's a biometric measurement patch that provides solution for patients with the end-stage kidney disease. It has an architecture with a Bluetooth, with a microcontroller, an interface, of course, an IoT gateway that will be examined most of the cybersecurity challenges, and it targets the remote patient monitoring system. We have 2 different scenarios for this specific case study. Is the balance, the patch to provide data for healthcare professionals in order to monitor and support the fluid management of dialysis patients remotely. And the second one is to provide the data directly to patients for self-monitoring of fluid level. The second case study is a medical device, a wearable medical device related to patients with movement disorders, and more specifically the Parkinson's disease. And it's a non-invasive medical device. The PD monitor is constituted of different components, cloud-based architecture, the smart box, a physician tool, and a mobile application. Here is the architecture of the PD monitor. Actually, the PD monitor is a sensor, is a device that captures motor data, and they're provided in the physician tool in the platform. So in NEMECYS, different scenarios of the PD monitor will be examined. So the patients will use the PD monitor daily in their home in order to track symptoms. All this data will be uploaded to the cloud, and there will be a standalone software that will communicate, of course, with the PD monitor in order to evaluate the advanced therapy settings that the specific patient needs. And the patient will use the mobile application in order to receive these changes recommendations for the advanced therapy. And through the Bluetooth, the mobile application will communicate with a standalone software in order to apply the advanced therapy to the patient. This was the first scenario. The second one is the patient that will use the PD monitor in order to evaluate their sleep throughout the night. So the data will be uploaded to a dedicated server, and the standalone software again will be paired with the PD monitor and will evaluate through artificial intelligence algorithms the sleep stages. And of course, the clinician could assess all this information through a dashboard. The third case study is a mobile application, a Class 2B mobile application, in order to support patients with diabetes capable of connected to other medical devices and a remote server. This is the architecture of the medical device and how it will be connected either to apply AI algorithms to the data or to integrate it and communicate with cloud infrastructure and the hospital or the healthcare provider, IT. The scenario for the mobile application is that will be designed in order to track a variety of features and information related to diabetes monitoring. So the biotech, which is the lead of the third case study system, will store all the data from the patients locally and, of course, in a remote database, and that can be accessed by the clinicians. Through a web application in order to evaluate the data of the patients. The fourth case study, it's a hospital-based point of care testing, and specifically it's CGM, a continuous glucose monitoring device, in order to measure the glucose levels. And it's the Freestyle Libre 2 device developed by Abbott that is used in the hospital, in the OSR hospital that leads the fourth case study. So here's the architecture of the Libre 2 device, and basically there are 2 different scenarios that will be examined in this case study. The one scenario is by using the mobile application and the physician tool directly, and the other one is by the reader, that the patient takes the reader at home and evaluates the glucose level directly from the home, and then the patient goes to the hospital, and the clinician evaluates, of course, through the platform the data that the reader captured. There is a manual data transfer, as I said, with the reader and the hospital directly. And here, also in NEMECYS and us, the rest of the project, we have a mission to provide feedback to the MDCG, to the coordination group. So our plan here, we have already conducted the requirement analysis, incorporating the MDR and IVDR. We utilize the feedback derived from the literal systematic review, that was conducted in the Warwick Package 1 in order to find gaps and find the best practices and recommendations from other documentation in the literature. So we developed a checklist summarizing the guidelines outlined in the MDCG. And this will be cross-reference with the specific NEMECYS tools in order to see which of our tools that will be developed can address, let's say, these specific guidelines. So here is, as I said, the methodology, an Excel file, how have conducted the MDCG assessment. Basically, it's the section from the MDCG, and the description is the actual guideline mentioned in the MDCG, and which of requirements are addressed from the MDCG in a specific column. And based on this Excel file, our strategy is to collect feedback from our case studies and see how these guidelines can be fit into the scenario that have been described in NEMECYS. This was my presentation. Thank you for your attention.
So, Christos, thank you very much for highlighting NEMECYS tools in detail and explaining how they can serve connected medical devices, and for introducing us to the project's case studies. So we have, you're welcome. We have now reached the end of our presentations, where we heard more about these Horizon Europe projects and how they're working to boost cybersecurity in healthcare. I can see that currently we don't have questions in the dedicated section, which is also fine and can mean that our speakers did a good job in presenting the projects in a clear way. So I want to thank the speakers for their time on behalf of the projects they are representing, and participants for joining. As said, the webinar will be distributed in due time. I also want to mention that these projects have newsletters. They are on social media. They have a dedicated website. So go and check out the cool work that they're doing in boosting cybersecurity in the medical field. I'm personally looking forward to seeing how these projects can collaborate in the future. So if there are no further questions, I wish you all a great rest of the day.